From the god of thunder to the heart of the modern civilization, it's the pulse of every human being, and at the same can take your breath away. Well, let's explore the ordinary and let's dive into the realm of electricity and try to visually understand in a very simplified manner what electricity actually is. So to understand electricity, we'll first have to understand what charges are. We know that like charges, they repel each other, and opposite charges, they attract each other. Well, to simplify this, let's see how electric fields interact with these charges. The electric fields propagate in an outward direction in a positive charge, and it's the opposite direction in a negative charge. So electric field lines go towards a negative charge and away from the positive charge. Now, using this concept of electric fields, we can clearly see that why opposite charges attract each other, and on the same lines, why like charges repel each other. It's because of a property that electric field lines almost never intersect. So we can see the repulsive force and the attractive force on charges. So one thing that we should have very clear in our heads is that these charges, they move around because of the electric field, and they move only because of the electric field. Not because of voltage, not because of current. It's the electric field strength that governs where and how much do these charges move. Just keep these few things in mind. That's it. Now that we have a hang of charges and what they are, let's try to understand what is an atom. So atoms basically have a nucleus in the center which contains a positively charged proton and a neutrally charged neutron. And on its shells, we have the electrons, which are negatively charged. So now let's try to calculate what is the total charge on an atom. So in this atom, there are 3 protons which have a total charge of 3, followed by neutrons which individually have 0 charges. Then we have 3 electrons which accumulates to -3. So net charge on the atom would be 3 protons plus 0 neutrons plus -3 electrons, which is equal to 0. So the net charge of an atom which has electrons, protons, positively charged, negatively charged elements is 0, which is mind-blowing in a way. Nature has its own way of balancing out everything. Now before we move forward, take a deep breath and open your mind for intense learning. So in the atom, we have the nucleus at the center of the atom and around which the electron moves. So these orbits are also called as shells. Now these shells have a property in which they can hold a particular capacity of electrons. First shell can hold 2 electrons, the second shell can hold 8 electrons, the third shell can hold around 18 electrons, and so on, with the general formula of 2n squared. Now the outermost shell is of major importance. It's called the valence shell, and the electrons that are there on the valence shell are called valence electrons. These are also very important in terms of its properties. Well, some atoms will have all the electron spaces filled. Some will have half of the electron spaces filled. Some will have 2 filled. Some will have only 1 electron in the valence shell. Now the question comes in, why did I bring up valence electrons and full-blown chemistry and physics together? Well, now we're talking about conductors. Now to understand what conductors are, we have to understand what valence shell and valence electrons are. Now if you look at the best electrical conductors in the world, we'll find that all of them have just 1 valence electron. It means they can easily give off that electron to the neighboring atoms. Now for something to conduct electricity, the electrons must jump from the valence band to the conduction band. It means you have to give them that energy to basically excite them to jump to the conduction band. And when electrons jump to the conduction band, they become conducting. In insulators, we see the gap between the valence band and the conduction band is huge. Now if you look at the conductors, we'll find that the bands basically are very close to each other, and at times they even overlap each other. Now conductors with very small amount of energy can start conducting electricity. So now we understand that conductors have free electrons in them. So a question might pop up that if conductors have free electrons in them, then they should produce electricity, right? Because electricity is nothing but movement of electrons. So let's just zoom inside a conductor and see what exactly is happening. Now as we can see, there are a lot of free electrons inside the conductor. But these electrons are randomly moving in every direction. even though there are a lot of free electrons in the wire, just because they are not coherently moving in one direction, the overall effect of the electrons becomes zero. So because of the randomness of electrons, there is no current produced inside the wire. This is the reason why conductors don't spontaneously produce current. Well, now that we understand charges, atoms, valence shells and conductors, let's see how electrons behave inside a conductor when an electric field is applied. Here we can see that under the influence of an electric field, the electrons in the outermost shell gather the sufficient energy required to jump from the valence band to the conduction band, and even though the atom is still, but the electrons are transferring from one atom to the other, or we can say they're jumping from one atom to the other, and this propagation of electrons is happening in one direction. We can now say that there is a flow of electrons. The directional flow of electrons is very important, and that happens because of the electric field that's applied. So when a conductor is connected to a supply, like a AA battery, we can see that an electric field propagates from the positive end of the battery towards the negative end of the battery. There is a flow of electrons from the negative to the positive side of the battery. So when the electric field propagates from the positive end to the negative end, there is a flow of electrons in the opposite direction, from the negative end of the battery to the positive end of the battery, and this flow basically produces current. To simply put, when a switch is turned on, the electric field is produced from the positive end to the negative end. The electrons start moving from the negative end to the positive end, and there is a flow of current from the positive end to the negative end. So remember that the direction of current will always be in the opposite direction of the flow of electrons and in the same direction as the electric field. Today our IQ points have shot up fucking 10 points. This feels hectic, but I think got a little smarter. So that's it, guys. This is what electricity is. With that, stay smart, be creative, drink some water, and I'll see you in the next video with resistance, voltage and current. See you guys. We'll catch you in the next video.